Hello everyone, Earth.Otherwise here to continue our journey through game programming in C++ start to finish by Earth.Otherwise. The main menu, which we are doing today, will contain the starfield background, a menu of buttons, 2 asteroids, which will be 2D, and the title of the game. Before we get to programming, we need a couple more .dlls. These are from the main CEGUI folder, build in bin. They go into our main release and debug folders. The .dlls have the same name, but _D goes in the debug folder. They include CEGUI Silly Image Codec, CEGUI Expat Parser, and CEGUI Core Window Renderer Set. To make our main menu, we first need to create a new class in our engine called GUI. Here, we will pound include glm/glm.hpp, sdl/sdl_events.h because we don't need window management from SDL, just inputs, CEGUI/CEGUIH, and CEGUI/renderer-modules/OpenGL/GL3renderer.h. Since we're using CEGUI in our engine, we'll need to include the CEGUI libs we added to our game program last time. Add those to your engine's librarian properties before moving on to the .h file. Put everything in your namespace. Just like our graphics resource manager, this GUI class will handle all GUI-related needs across all of our states and hopefully games. In public, add void init passing in a const std string reference called resource directory. Next is a void destroy, then void set mouse cursor passing in a const std string reference called image file, void show mouse cursor, void hide mouse cursor, void input GUI passing in an SDL event reference to event, void update, which will be used to update CEGUI's internal time count so that animations play correctly, a static CEGUI OpenGL3 renderer pointer called getRenderer, that's the function name, which will return an mGUI renderer. Next is a const CEGUI GUI context pointer called getContext, which will return the member variable context. Then void load scheme, passing in a const std string reference scheme file, and then void set font, which passes in a const std string reference font file. So that we can have buttons in our menus, we need CEGUI window pointer called create widget, passing in a const std string reference called scheme and name, and 2 const glm vec4 references called percrec and pixrect. Then we need a setter for the above, the function that returns a CEGUI window. This will be a static void set widget rect, which will take CEGUI window pointer called widget, which will be the member variable, and the same 2 glm vec4 references, and finally void render. That's our last function, is void render. In private, our member variables are going to be a static CEGUI OpenGL3 renderer pointer called mGUI renderer, a CEGUI GUI context pointer called mcontext, a CEGUI pointer mroot, which is equal to a null pointer. This will be our root window that all other buttons will look to. And finally, an unsigned integer called mPreviousTime set to 0. In the .cpp file, we'll need to include sdltimer.h. Then we will initialize our mGUI renderer to a reference to CEGUI OpenGL3 renderer bootstrap system. That's a function. This is all, by the way, in init. Then we set up CEGUI's resource manager. CEGUI default resource provider pointer, called resource provider, is equal to a static cast of CEGUI default resource provider pointer, and that is CEGUI system get singleton function dot get resource provider. That will give us a resource provider for CEGUI. Then we set mPreviousTime to SDL get ticks, which will set our previous time variable to the current amount of time that has passed in our program. Now we can actually start setting our resource directories. We're still in init. First will be image sets. If we like, we can create our own image sets later. Using resource provider, we call setResourceGroupDirectory, passing in what kind of directory it is. In this case, it's image sets, and the resource directory we passed into init, plus /image sets /. Copy and paste this 6 times, and we'll replace the word image sets with first schemes, then fonts, layouts, look and feel, and Lua_scripts. Now that our resource provider knows where things are, we need to tell it to use those things using the following lines. Each of these are first CEGUI, all 6 of them, and then input manager set image set default resource group to image sets. These have to copy the words that were in our previous set of 6. Next is scheme, and then set default resource group, schemes, and then font, set the default resource group to fonts, and then widget look manner, set that to look and feel, and then window manager, set that to layouts, and then script module set to Lua_scripts. Now we initialize our mContext to the address of CEGUI system get singleton IO dot create GUI context, passing in mGUI renderer pointer arrow get default render target. Not entirely sure that it should be get singleton IO. It might just be get singleton, but just do whatever I'm typing on the screen. I knew what I was doing when I typed it out. Then we initialize our mroot to CEGUI window manager get singleton dot create window, passing in default window, the words, and root, the word. And then passing in our new root window to mContext using set root window. Down in load scheme, new function, we call CEGUI scheme manager get singleton function dot create from file, and we pass in our scheme file. In get font, we call first CEGUI font manager get singleton dot create from file, passing in our font file, and then adding dot font. Then we use mContext arrow set default font and pass in the font file from our parameters. When we're creating the font, we use dot font, but when we are setting a default font, we do not use dot font, which is why those two are different. Next, in create widget, we create a CEGUI window pointer called new pointer, and we set that to CEGUI window manager get singleton dot create window, and we pass in a scheme, which we passed into this function, and name, which we also passed into this function, which is a const string reference that I originally forgot to add to the parameters in the .h file, so I'll change that now. I mentioned it, I didn't actually add it. Then we call setWidgetRect and pass in the percrect, which stands for percentage rectangle, which is the percentage from 0% to 100%, the distance from the top left corner of the screen, and then pixrect, which is the pixel offset from the top left of where the percentage is to wherever you want it in number of pixels. Add that window to the root window with mroot arrow add child, passing in new window. All widgets need to be a child of the root widget or a child of the root. Finally, we return new window because this function returns that. Now down in setWidgetRect, which as you'll remember we just called, it is a static void and does not return a value. We set the widget using widget arrow set position, passing in a CEGUI uVector2, which takes two CEGUI dims as parameters, which each take two floats. The first float is the percentage of the parent widget, and the second is the second float is the pixel offset of that percentage, which I just mentioned. First udim is x, second is y, obviously. Then we set the widget size using setSize, which takes the same stuff as setPosition. It's pretty much the exact same line, except instead of a uVector2, we're using a uSize, and we use the z and w of the vec4s that were passed into setWidget. Now in destroy, we need to free up our memory in case the game keeps running after we've destroyed our our widgets, which it most likely will because this is the main menu. We will call CEGUI system get singleton destroy GUI context, passing in a dereferenced M context. We dereference M context by using the star symbol. Then in render, we need to call our mGUI renderers begin rendering function. Then we call mContextDraw. Then we call mGUI renderers end rendering, and ending with a GL disable the GL scissor test, as CEGUI uses OpenGL scissor test to discard certain pixels, and that can interfere with our own rendering. We'll have to include gl/glue.h at the top for this to work. In fact, at the end, we're going to be adding a bunch more stuff to this function because CEGUI does a bunch of stuff that we're going to want to disable or re-enable our version of. Now down in the setMouseCursor function, we need to have our mContext call getMouseCursor.setDefaultImage and pass into it our image file string. This will give us the arrow on our screen. It will give us a custom one. In showMouseCursor, we need to let the player see the cursor with mContext getMouseCursor.show. And then, of course, hideMouseCursor is the exact same as showMouseCursor, but with hide instead of show. Now, before we can do input text, which is the next function that was from our .h file that we're going to be doing, we need to be able to translate the SDL keyboard keys into CEGUI keyboard keys. To do that, we take the function that is linked down in the doobly-doo under SDL to CEGUI key translation, and then we're going to alter it slightly to bring it up to date. We do this by changing SDL key to SDL underscore keycode. Then we change SDLK underscore KP0 to 9 to SDLK underscore KP underscore 0 to 9. We're just going to remove numlock, scroll lock, and the window keys since we're almost certainly not going to use any of those. Then we're going to make the default return key unknown. Finally, we're removing the return 0 since all cases return something. Then we need a mouse button conversion, which is a new function, and this is simpler. It is going to return a CEGUI mouse button, and it's called SDL mouse button to CEGUI mouse button, and it passes in a uint8 SDL button. we'll use a switch statement, just like the previous thing, to switch using SDL button. Our first case will be SDL underscore button underscore left. Our following cases are SDL underscore button underscore right. They're all SDL underscore button underscore. And then we have middle, X1, and X2. They are going to return in order CEGUI mouse button. All 5 of them have that. Left button, right button, middle button, X1 button, and X2 button. Default is going to return CEGUI mouse button, no button. Another function we'll need so that we'll be able to input text to input GUI will be called decode input text, and it will take an SDL event reference called text event. It is going to create a CEGUI UTF-32 called code point, which is set to 0. Then we set text event.text.text. We're going to set that to an std string called text event, or rather we're going to set text event equal to text event.text.text. Then we create an std vector of ints called UTF-32 result. Now we convert SDL's UTF-8 to CEGUI's UTF-32 like this. UTF-8 : UTF-8 TO32 function passing in text event.text.text for the first 2 parameters. The second parameter is going to be added to with event text.size, with the final parameter being std : back underscore inserter, which is going to pass in UTF-32 result. Then we're going to set code point to the first element of UTF-32 result and cast it to a CEGUI UTF-32. Then we use mcontext arrow inject char, passing in our code point. Now what we just did was we took a character in one format, a letter like A or Z, and we translated it to another format. It's still A or Z, but now it's just written a different way. And we do that because SDL sees letters in one way and CEGUI sees letters in the other way. So if we're going to pass a letter from one to the other, we have to translate it. Now, in order for the UTF-8 function that actually does the translation to work, we're going to have to do a little extra work that I've forgot about up till this point. First, download UTF-8-CPP from the link next to UTF-CPP. Then copy the files from the source folder into a new folder in our include directory called, all caps, UTF-8-CPP. Then include at the top of this .cpp file UTF-8-CPP/UTF-8.h. That should let that little translator work properly. All of that should convert the text from SDL to text from CEGUI. If we want to dive deeper into Unicode translation, as we might for a commercial game, we can look at the link below UTF-8-CPP, which is all about translation and a library that can do that. But moving on, in input GUI, we will use a switch statement to find out what kind of input our GUI has received using event.type and checking for the following events. Essentially, this is exactly like our input handler, but specifically for things related to the GUI. First, the first case, as this is a switch event, is SDL underscore. They're all SDL underscore, and they're all caps. Mouse motion, then key down, then key up, then text input, then mouse button down, and then mouse button up. In order, they will be telling our GUI the following: the mouse position for mouse motion with mcontext arrow inject mouse position, passing in event.motion.x and event.motion.y. Then key down is going to have mcontext inject key down, passing in our key conversion function, if you'll remember, SDL key to CEGUI key, into which we pass event.key.keysim.sim. Key up is the same as key down, but with up instead of down. Text input will call decode input text and pass in our event. That's all it has to do. Mouse button are just like the keys. Using mcontext, we use inject mouse button down, passing in our SDL mouse button to CEGUI mouse button. That's the function we use, and then we're passing into that event.button.button. And the same is for mouse button.up, but with down changed to up. Moving on. In update, we need to call unsigned int current time, that's a new variable, then unsigned int time elapsed, which is set to current time minus previous time, which is a member variable. And then we use mcontext to inject time pulse, passing in a float cast of time elapsed divided by 1000 because the CEGUI takes time as a floating point number of seconds. This way, animations will play correctly if they do exist. So that is all we need to do here in GUI in our game engine. Now, in our little test game, we're going to create a main menu class, and then we're going to #include graphics resource manager and GUI.h. In public, we're going to add a void init function, which takes an otherwise graphics resource manager pointer as a parameter, then void main menu loop, a render function, and an exit function for our main menu exit game button to call, which needs to return a boolean and take a constant CEGUI event args reference called E. And then we will also have a begin game function for our main menu start button to call, which also needs to be a boolean and takes the same arguments as the exit function. Ignore the fact that the first time I wrote this, when I was recording, I wrote start game. It is actually begin game. Member variables include our pointer to the graphics resource manager object, a GUI pointer called mGUI, a boolean called mStartGame, which is set to false. Now, over in the CPP file, in the init function, we'll set our member graphics resource manager pointer to the pointer that we passed into the init function. If, for some reason, you get an error in your CEGUI included file headers, check where you originally got the CEGUI folder, which is in your include folders inside your dependencies, and make sure that you copied all of the files there. If you missed any of them, it can lead to problems. In main menu loop, we'll first pop back the last 3 sprites in mGraphics Resource Manager mMultiSprite 2D, which will leave us with the Starfield background, which fills the first slot. I just realized that we can't do that correctly. So I'm going to quickly pop into Multisprite and add a function that will allow us to call popBack on the multisprites in our graphics resource manager. Then we will create our GUI in our main menu loop, I believe. Yes. First, we need the scheme, which we set with mGUI arrow load scheme, passing in Taharez look.scheme. Then we'll set the font with mGUI arrow set font, passing in Deja Vu Sans -10 for our temporary font. We'll create 2 push buttons of CEGUI push button pointer called start button and exit button, using a cast to push button of mGUI arrow create widget, passing in Taharez look /button, and then GLM vec4 0.5, 0.5, 0.1, 0.05, and 0.5, 0.4, 0.1, 0.05 and then both of them will have a second GLM vec4 of 0.0f. And they will have the names start button and exit button. Essentially what we just did was the first GLM vec4 put the buttons onto the screen, and the second one is pixel offset. We're not doing any pixel offsets right now. You can if you want to, but you don't have to. Now, we're just using the default button for now, and we may make one later, much later. But now we'll set the text with start button, arrow set text, passing in start with the same function, but exit for the exit button. Now we'll tell the buttons what we want it to do by using subscriber event, passing in the event type CEGUI push button, event clicked, and the subscriber of CEGUI event subscriber, passing in the address of main menu, then the function begin game and exit game in respectively, and then the object that we want to use that function in, which is a pointer to this object. Then we'll make a box that we can input text into. A CEGUI combo box pointer called text box is made using a static cast to a CEGUI combo box, and it's with MGUI arrow create widget, passing into create widget taharez look / combo box, and two GLM vec4s with a slightly different position of 0.2f, 0.2f instead of 0.05f, 0.5f, and 0.5f respectively, and we're going to call it type box. You should be looking at the screen because this is probably making no sense. Now we set a custom mouse cursor using mgui.setMouseCursor, passing in taharez / mouse arrow. I think that should actually be taharez look / mouse arrow. I fix that later. Followed by mgui show mouse cursor. It is shown by default, but we're just being careful at this point. Then we want to disable our default mouse cursor by using SDL_show cursor, passing in false or 0. Now we'll copy the add sprites from game logo so that we can add our asteroids in our main menu. We'll of course have to change their positioning and size, but I'm sure you can determine what needs to be done there on your own. You can also probably find your own, sprites for it. I'm just using gray octagons because I'm boring. Then we need to include spritefont.h and copy our sprite font from main.cpp into our main menu. We'll of course change the text to whatever we're going to call our game. I'm going to call mine Bad Asteroids Clone, because if you'll remember, you won't because I didn't, we're actually making an asteroids clone. And we'll need to find a place to put these these letterings. I'm sure you'll find a place for it. I'm not going to tell you how to arrange your art more than I already have. Now we'll create our while loop that checks if mStartGame is false, which it won't be if we're moving in, unless we're moving on into the game proper. This while loop we'll call render, mgui arrow input GUI, mgui arrow update, and mgui arrow render. But in order for input GUI to function, we'll need to copy a couple lines from input handler and get an SDL_event and pass it into input GUI. In the render function, we'll copy our game logo render function, as this will be exactly the same. At the end, we'll draw our GUI using mgui.draw, or arrow draw as it will. This would also be a good time to remember that we need a camera, program ID, perspective uniform, orthographic matrix, and we could probably use the screen width and screen height. It's a good thing that we can also copy all of this from game logo as well. Now down in the exit function, we'll shut everything down using SDL quit and exit with a number. Now, this reminds me, we can't call this function exit. We have to call it exit game because there's already a function called exit. So I'm actually going to change it to exit GUI. exit game works just as well. The name isn't all that important so long as it doesn't conflict with other names, which it did before. In start, we'll set mStartGame to true and return true. That's the start button function. Now in main, we'll include GUI-H and mainMenu.h, and then we'll create a GUI and a main menu object called Graphical User Interface and main menu respectively. Then we'll initialize them, passing in GUI as our resource directory, and passing a pointer of the GUI into the main menu, along with all the stuff we passed into game logo. A bug I noticed: when setting the functions that are to be used by buttons, remember to create a pointer to that function by adding a AND symbol to the front of the call. I also placed the closing brackets on the wrong side of the this call. Additionally, functions that are called by buttons must pass in a const CEGUI event args reference. It has to be constant, it wasn't before. If you have strange linker errors pertaining to OpenGL3 renderer, try adding this line of code above init in the .cpp file. CEGUI OpenGL3 renderer pointer GUI mGUI renderer is equal to null pointer. If that doesn't work, try using CMake again and recopying all of the files from the CEGUI folders. You may need some additional files from the main CEGUI folder, build CEGUI include. Check there if nothing else is working. Now, remember what I said last time about us needing .dlls from CEGUI, dependencies build, that's the folder directory? Well, now I've decided to just put all of the .dll files into the release and debug, because I was having some massive troubles with them being missing. We also need to remember that the graphics resource multisprites don't need to be initialized a second time, which I tried to do when I was copying init lines from game logo. Also, in setFont, Taharez look is not a font, which is what I wrote. If you were listening, then you knew that I wrote the wrong thing. It should be Deja Vu Sans-10. We also need to load our scheme, which I didn't do properly, even though I said I was supposed to do it. We load that into memory using mGUI arrow load scheme, passing in the name Taharez look. Furthermore, in order for our main menu to use a GUI, we actually have to pass it in, making meaning a GUI pointer becomes a parameter for our main menu init function, which is then used to set our internal mGUI variable. I did not do this if you were watching. Additionally, Taharez/mouse arrow should be Taharez look/mouse arrow, and the render function for the GUI has to be in the main menu render function, so it's changed by the perspective and shaders. Finally, the last thing you're going to want to do is in GUI render, before you call begin rendering, use GL disabled, the GL depth test, and after you end rendering, we'll need to enable and disable a bunch of stuff. The list is as follows. We're going to use GL bind vertex array to bind the array 0. We're going to GL disable the GL scissors test. We're going to GL enable GL blend. We're going to change the GL blend func back to GL underscore source underscore alpha and GL underscore 1 underscore minus underscore source underscore alpha. We're going to GL bind texture, a GL texture 2D. We're going to bind 0. We're going to GL disable the client state, GL vertex array, and same thing 2 more times, except with GL color array and GL texture coord array. Anyways, this has been Earth.Otherwise. Thank you for watching. I hope you were able to keep up with me with all of that, really. If you weren't, let me know in the comments below, and I might slow things down. I am trying some new stuff here with how I'm putting videos together. Anyways, as I mentioned, thank you for watching.